Excellent. So we're closing in on 1/4 past, and I hear it's the bell is ringing. So we're currently 102, 103, and yeah, we'll see how far we get before it's 1/4 past.
Can I ask something, or more?
Yeah, sure.
More of a statement. So I struggled a lot to use an editor using the SSH, but I talked to the assistant fellows, and they told me I can't use Atom through SSH since the computers in KTH probably don't got Atom.
Mm-hmm. Well, actually, it has Atom, but it's complicated to make it work.
Yeah.
Since it's so if you want to do editing on student shell, then you'd better get used to one of the text-based editors, so like Nano or Vim or Emacs.
Okay.
It's always nice knowing a text-based editor, because sometimes you encounter a system and you need to do something and it doesn't have a graphical user interface. So so that's nice.
Yeah, so we're getting a couple of questions. Why is it Atom recommended? So the way we have these assignments set up, we're trying to cover a lot of topics. And normally when you're working with version control, you're cloning repositories to your local machine and you're using the text editor that you've set up on your local machine. So hence, that's normally how we'd be doing these labs, but we added the remote aspect because, yeah, we think that's kind of important, that you should be able to log into KTH machines in case you're in a course where there's some software that's only available on those machines and only accessible through the terminal. So you have that knowledge. But because all the 3 tasks are squeezed up together, it sort of feels like, okay, we should do everything the same way. So that might be a little bit confusing, and we appreciate that. So we're just trying to cover as many possible topics as possible. Yeah.
So let's see, it's 16 past now, so we can get started. It's 156 people present, so that's nice. See, so there is some discussions in the chat how to move your or copy your vimrc file to the KTH system, to student shell. So the line I wrote there will put it in your home folder. So so if you're standing in your home folder, you can just write that line and it will be fine. And so the vimrc file is the configuration for Vim. So if you've set up Vim, you can just copy it to your home folder on another machine, and Vim will be set up and nice, ready to use. So let's get started. I'll find my slides. So I hope you see this. So let's get going. So I have quite some slides today. We'll see if we make it through all of it in 45 minutes. But let's dive in. So TeX was created once upon a time by the father of computer science, Donald Irving Knuth, at Stanford University. This was at the end of the 70s. So he has written a very famous book, or well, a series of books, I should say, because it didn't fit in just one book. So it's a book consisting of several volumes. And at the end of the 70s, when he published the second volume, he was very unhappy with the result, because then the publishers had started moving to digital typesetting, and it looked like crap. But then he figured that hey, this is stuff I know. They are using computers, so I can actually make a contribution here. So he started writing TeX, and he also wrote a system called Metafont, which is the system for fonts in TeX. And in 1985, Leslie Lamport created LaTeX, or LaTeX. And this is basically, you can see LaTeX as a library of ready-made stuff that makes it much faster to produce documents than using plain TeX, as Knuth himself did. So we will focus on LaTeX, since we will look at report writing and stuff like that to make everything go very smooth. But you can use TeX for a lot of different things. So it's quite powerful. So I mean, you can typeset maps, musical notes, and this one is kind of cool. It's just a document of text, and the margin is set to be circular, and this is produced automatically by TeX. You just need to set it up, and then you type your text, and it will make it look exactly like this. And you can do other stuff like write in Tolkien's Tengwar font and language. So you can do quite cool stuff with TeX. Anything is possible. But let's move to LaTeX, and we'll start with the document structure, what it looks like. So all documents need what is called a preamble, and this one basically contains the setup for the document. So it should always start with this document class, which says what type of document we are writing. And right now I set it to an article here, but you can have a report or a book or something like that. There are a few predefined for document classes that you can use. And for short reports in classes in the courses that you will have, if you ever need to write something, it's most likely an article that you use, because a report is much larger. So an article is perhaps up to 20-ish pages, and then a report is like 50 pages and onwards, because then you get bigger chunks you can divide it in. We'll get back to that. And then LaTeX has packages that you can use, which changes the behavior. So you see I've loaded 3 packages here. So the first one is the input encoding package, and we want to use UTF-8 because by default the TeX and LaTeX processors will use US ASCII 7-bit, which means that a lot of characters don't work as intended. So like O, Ä, Ö doesn't work. And also if you need to use any accents, if you have a French name in there or even a Swedish name with an accent, it doesn't work as expected. So UTF-8 is really nice to do. And the font encoding, so this is also these two lines you will basically use in all documents you ever write. So the font encoding, that helps producing PDFs which you can copy the text from, and it will actually give you the expected result. Because if you don't change the font encoding when you copy the text, an Ö will be an O with 2 dots above instead of an Ö. So this one ensures that you can copy paste as expected. So if you skip this line, you will give a headache to anyone who wants to copy text from your PDF by selecting the text. So just always use these. And this package, Bobble, helps with translations. And now I've loaded 2 languages, English and Swedish, and it's the last language that's the default. And this means that I will get all the automation. So for instance, when I create a table of contents, it will not say table of contents in English, it will say innehållsförteckning in Swedish, for instance, which is things you want. And instead of saying figure in English, it will say figur in Swedish, and tabell, and so on. So it will translate all of these automated things that you will get, but we'll get back to that. And then, of course, the setup that you will have to do every time. I mean, a document needs an author. In this case, it was me who wrote it, and it needs a title, and it needs a date. And you can always use the today that will put in today's date for you. So this is a small preamble, and most likely you will use more packages than this in the future, but this works as a short example. The other part is the main text of the document. And this comes between a begin document and end document. So the preamble is what's before begin document. So you see here, the first 8 lines is the preamble, and then 9 and onwards is the main document here. And the first thing I put in is a make title command, which will create a nice title page for us. And then the table of contents command, which will insert a table of contents. And then I just put 3 dots here and end the document. And then the result will look something like this. I can open it in another editor to show you that in a bit bigger form. See there. Let's open it in Overleaf, so you see what that looks like. So Overleaf is, yeah, what I recommended you to start with, because that one makes it really easy, and the tutorial that is linked for learning tech, that one uses Overleaf. So you can get all the examples into Overleaf and play around with them. So start with that one. So it sounds like some people are not muted. So let's play around with this one so you get to see what it is. And as you can see, I have made this one look a bit like Vim with a dark background, and I even have Vim key bindings in it. Still, it's not Vim, but at least I don't have to use the arrow keys to move. I can use Edge JKL to move around. So this was exactly the setup that you saw in the slides. So let's remove this title command by commenting it out like that. So comments in LaTeX starts with a percentage sign, and that means the rest of the line is completely ignored. So I commented this one out, and let's recompile and see what happens. And now it took away the title and the author and everything, and left is only the table of contents, which doesn't contain much. It's just the title. So let's keep this one back, and let's write some text. Or we can write in Swedish, since that is the default language. So let's recompile. And now you see the text appeared here. So this is yeah, basic setup. Let's go and look at something more fun. What else we can do here? So let's switch back to these slides. Okay, so let's look more at the main contents. What can we do? So as you saw, as you just saw, normal text is just written as normal text. And paragraphs are separated by an empty line. So for instance, this is one paragraph and this is another paragraph. So you have a blank line here between. Then these are separated as two different paragraphs. So we can switch back and see what happens here if we add some another paragraph here. Okay, so now I've added two paragraphs here. And let's see what happened here. So it looks like there's no blank line between these two. And that's because, let's put in some more text here and see what happens. Hammering the keyboard. So that's because by default, this document class is set to use indentation. So even if you mark in the source code a new paragraph like this, it will mark paragraphs by indentation in your document, in the result. And if you want the blank line paragraph separation in the actual document too, there is a package which changes these settings. So if you read through the tutorial, they will tell you about it there, what's its name. So let's get back. So sectioning, a larger document needs some sectionings, and the chapter sectioning, that one is available in bigger classes like book and report. So that's why you probably want the document to be at least 50 pages for starting to use chapters. So a large report or a thesis or something. The section command, that one is available in all classes. So for instance, in this article class that we're using in the example, and that is in small reports that you use in small courses, so up to 20 pages long, then you can use the article class, and then section is the biggest sectioning tool of the document. And then of course you have subsection and subsection and named paragraphs. So let's see what we can do with those. So switch back to overleaf here. So we start so let's start this section here, and then we want the subsection. So let's try this. So now we have a section and a subsection, and let's recompile and see what happens. So you see, now we got the first section here, and this text is part of the first section. And you might notice here that now it didn't indent this first part of the text here, because in correct typesetting that shouldn't be the case. This one should be indented to indicate this is a new paragraph starting, but this one shouldn't. So Tech fixes this for you. And we see that the subsection is typeset smaller. It has 1.1, so it's a part of the introduction, and we have a new paragraph starting here. We can also see that we started populating the table of contents, because this one uses the sections. So then you see that you have the main section here. It starts on page 1. Yes, indeed, it's page 1. And then it has a subsection that's part of it, and it has some nice dots here, so you can easily go see which page it starts on. So you get a lot of automated things when you start writing stuff in LaTeX. So you don't have to bother with table of contents and the numbering of the sections and things like that. So Tech will take care of that for you. So let's get back. Well, we can show a named paragraph too, just for the sake of it. So let's add a named paragraph at the end here. So you see a named paragraph that's simply, it has some bold text here. It's usually unnumbered, and then the text follows directly afterwards. So that's a really small type of sectioning. It's the smallest type of sectioning, I should say. So let's switch back to the slides. And yeah, so there's some other things you can do too. For instance, sometimes a section will have a very long title, and that's usually fine within the document. But in some document classes, for instance, prints the title at the top of the page, like you can see in books. So then you keep track of which section you're currently in. And also in the table of contents, it might look ugly to have the full title. So you can write an optional short version of the title here, which is a bit shorter. And you see here that these are curly braces and these are sharp cornered braces here. In LaTeX, the curly ones, those are used for mandatory arguments. So of course, a section needs a title. You can't have a section without a title. So then you put those in curly braces here. But it doesn't necessarily need a short title, because the full title might be short enough in itself. So everything with these sharp ones, the square brackets, those are optional arguments. So you'll encounter that in several places. So we saw, for instance, that when we loaded packages, we passed some options, like for instance, for the input, we passed UTF-8. That one was in square brackets, because the packet doesn't necessarily need to have to get any options. But in that one, we really want to pass something. So there are some other useful packages to, for instance, handle references. So for instance, if we use the bibliothèque package, then we can add a bibliography. In this case, I called it literature.bib. We'll get back to the contents there. And if you have an entry for Knuth 1997 Tau, so Tau as in the art of computer programming, then you can write things like this. So according to, and then this text site here, there is no algorithm to solve the problem. And at the end, you have a print bibliography. And this particular, so this part in the middle here will turn into this. So according to Knuth, who is the author of this book, there is no algorithm to solve the problem. So you will get a correct reference here. And in that literature.bib file, you have an entry which looks like this. So it has an author, Knuth, and title, art of computer programming, and so on. And you can actually get these citations in this format from most places. So like, for instance, in Google Scholar, we can actually look into that if we switch back to Overleaf here. So if we go to scholar.google.com, let's search for Knuth. And yeah, let's take this paper and we want to cite it, and then we can select BibTeX here. And then we get this code for it. So then it's just copy pasting it into the bib file. We can also get this for books through the Royal Library of Sweden. So if we search for a book, so search for the art of computer programming and volume 1, that sounds perfectly fine. And then you can create a reference, and then you get the BibTeX format down here. So then it's just copy pasting it too. Once upon a time, I actually wrote a script that probably still works, where you can get this on the command line. So you just need to type the ISBN number. So if you have a book in your hand that you want to have a reference for, you can just type that on the command line and you'll get it. So then you can just use a redirection into the bib file and you're set. So let's switch back. And of course, you can do maths, which is what LaTeX is and TeX is most known for. So for instance, we have this text, so we have the sum and then this thing, but we also have the sum and then see that it's just parentheses here, and here it's a square bracket. And the result is like this. It's the same sum here, but it's typeset differently. So here with the round ones, it's typeset to be in the middle of a sentence like this. So it's slightly smaller. You see that I and N here are on the sides, whereas here it's typeset to be on its own line. So then you can take some more space and do it more beautifully and put the I under and the N above and slightly bigger. So, and TeX has kind of set the standard for how to write maths. So like, for instance, if you want to put maths into a Wikipedia article, for instance, then it's the TeX syntax that you're using. And in a lot of other places too. So, Canvas, for instance, if you type TeX syntax there, it will turn it into this for you. And you can do some more advanced stuff. So for instance, this code here will turn into this. So you can easily typeset advanced maths. And yeah, there is documentation for that. So just search for AMS math and you have a lot to read. Another way of getting at that is to, let's see, let's get to a terminal. So you see my terminal here now. So you can just type TechDoc AMS math if you have it installed on your system, and it will actually open a PDF for you. So now I have to change the window I'm sharing. And then it will bring up this PDF for you, which is the user's guide for the AMS math package, which does a lot of stuff related to maths. So you have basically an instruction for how to do anything with mathematical equations and stuff like that. So if you read this one, you're all set. But there are instructions how to do maths and stuff in the LaTeX tutorial that you have linked from Canvas to. So let's go back to the slides. So note that sometimes you will encounter people using dollar signs and double dollar signs to type maths in a document. And this is plain text. So it should be used in some places, but most of the time you should use the square brackets and the backslash parentheses that I've used here, because that's the LaTeX way of doing it, which means that packages can affect how it's done, which means it will be typeset more correctly than if you use the dollar signs, because that's plain text. So that one can't be overridden in any way. But like Wikipedia, I think uses the dollar syntax to put math mode. So there, of course, you should use it, but not in a LaTeX document. So I see in the chat without the T, so TechDoc and then AMS math, and you will get the PDF if you have installed the TeX distribution on your local system. You can also do figures, and then we need a package GraphicX. And then you simply do somewhere in the text where you want the figure to be, or where you want the figure approximately to be, because LaTeX will put it where it's suitable, but in close proximity to where you put it in the text. Then you start a figure by begin figure and end it by end figure, and everything in between will be part of the figure. So usually you want the figure centered, and then maybe you include some graphics. In this particular case, we include tengwar.jpg, and we don't want it to be super wide and to have full resolution. We just want it to span 20% of the line width that we have. And then we want to have a caption, so a text describing what the figure is, and then a label so we can refer to it later. And then we will get something like this. So the caption will put a figure, and if it's in a document, not in my slides, it will also be numbered. And then the description, and of course the picture that we had chosen. We can also do tables. So we start those by begin table. Usually we want them centered. It depends. And then you start the table itself by begin tabular. And then you have to describe the setup of the table. So where you want it to be, if you want it to be right adjusted, centered, or what. And in this case, we have right aligned the first one, and the rest are centered. And then we have put some data here. So the columns are separated by this ampersand here, and the rows are ended by this double backslash. And then, of course, we want a caption here too, and a label, and then end table. So let's see what this produced. So this produced exactly this. So we see that we have right alignment in the first column, as we specified, and then everything else seems to be centered. And then we have the caption, which describes what the table contains. And then we have cross-referencing, which is also a very useful part. So we can see, we can write something like this in our text. To understand this text, you should see table and then a reference to the table that we had. So this table was had the label TBL probabilities. So if we write ref TBL probabilities, LaTeX will actually put a reference to table 1 if it was the first table, or table 2 if it was the second, and so on, depending on the numbering. But of course, there are packages that can be very useful. So you don't have to remember that this is a table and write out a table. So there is a package called cleverref, which lets you write this instead. To understand this text, you should see, and then cref, TBL probabilities, and then it will know it's a table, so it will put a table in the proper form in the text. So tabell if it's in Swedish, or table if it's in English, and depending on how you set it up. Yeah, so that makes life easier as well. So if you change the table to a figure, you don't have to change the text. So instead of a table, you have a graph illustrating this, then the text will still be fine. You don't have to update it, which you need to do in this case. We'll see a summary of all these examples in a little bit. So I'll just mention a few more packages that are useful and what you can do with them. So depending on what you will do here at KTH, you have the SI unit X package, which is used to correctly typesetting units. So in SI form, so like meter per second and stuff like that. Bibliotech I mentioned for reference management, and listings used to list source code, which you probably want to do in some reports sometimes. So for instance, the SI unit X package, well, we're computer scientists, so we load the binary units too, because that's what we usually work with. So then you can write something like a standard ruler is 30 centimeters, and it cannot measure data since that unit is in kilobyte. And then it will type it like this, and it will ensure that you have proper distance between the number and the unit, and properly typeset the unit as well. And if we put everything together, we get something like this, but let's show it in overleaf instead, so we can play around with it a bit. So here I have my browser. Let's go back to overleaf, and let's pick examples.tech instead. So here I put everything. Let's recompile it. So let's have a look here at the document. So you see we have the title as we had before. Now we also have an abstract, which is a short summary of the article. And we use the article class here too. You can see that we have a few more packages compared to before. So we still have Bubble, we have SI Unit X, Graphic X, book tabs, which is a nice package for getting beautiful tables, and then Bibliotech for referencing, and then Cleverref. So the abstract, that's simply begin abstract, end abstract, and you can see here that it adds the abstract title and typesets it in a nice way. And then we put the table of contents, and then we have some sections. If we look here, we see that math example that we had before, and I also put on this part, we put an equation, and in this case I have it numbered, as you will notice this in your maths book later, that sometimes you number equations to refer to them later, and that's done with the begin equation environment. We did the references and the figures as you saw. Let's go down here. So here you see that we have a reference to the equation, so equation 1, and we did that simply by entering cref and then the label of the equation. So if we check here, we had begin equation and then we had the label, the great equation. So then we did cref, the great equation here, and you see that cref automatically put in this for equation. So we know that it's an equation. And we can play around more with the units. So you can use this SI command, and you put the unit in there, or you have this capital SI, then you have the number and followed by the unit. So you can do quite a lot with this. And here I have my print bibliography. So we see that the Knuth reference that we had before here, so according to Knuth, then it says KNU97 here, and if you go down, it says KNU97, and then you have the full reference as it should be. So this was a very, very brief introduction to LaTeX. So hopefully, if you read the tutorial, you will get more details, and you will have more time to experiment as well. So then you can play around with these examples. I will share this source code too, so you have it. So I'll provide a link, because then you will get the source code for the slides too, which Overleaf can't really handle. So it shows some errors here, but it compiles perfectly fine. So it just messes with its syntax highlighting and when it's trying to parse the text code. So let's see if we can compile the slides here. Compiling.
Insert drum roll.
Yeah. And there we go, it's loading. Yeah. And hopefully you recognize these slides. So you see it's exactly what we went through. It couldn't do that one though, because that one is not compiled. I had automated its compilation on my local machine, but otherwise it looks fine. So yeah.
Yeah, we're getting close to the end.
Mm-hmm.
I just wanted to jump in. There was some comments about, given that the assignments disappeared for an unknown amount of time,
Yes.
has that affected the deadline?
Well, considering that it had disappeared sometime yesterday. So between Sunday and Monday at 3 o'clock, that's how we narrowed it down. So someone noticed that at 3 o'clock yesterday it was gone, but it was there on Sunday, someone else said. So it disappeared sometime during Monday, and I put it back now, so they are there. So it's not that long they were gone. So, but yeah, I mean, we can run the scripts for grading sometime next week. So still make sure you have handed everything in and done everything by the end of the week. And by end of the week, I mean, yeah, you have Saturday and Sunday too, if you like.
Okay.
Can I ask
that should still be fine.
Is
Yes.
there any way to see that you've done everything correctly?
Yeah, well, I have asked the TAs to try to run the scripts for grading, at least the first few assignments. Not sure if they've done that. I have to get back to them about that, and then I have to test the grading scripts for well, finished writing them actually for the LaTeX assignment to test and see that it actually works correctly. But for the first assignment, they should be able to run that script. Well, now that everything disappeared from Canvas, I suppose they have to rerun that. If anyone had gotten a pass on that, it's gone now, and they have to rerun the scripts. But the logs should still be there on student shell, so we should be able to extract that still. So it doesn't matter if you use NatBib for BibTeX for referencing. Yeah, you can use NatBib if you like. I would recommend you to go for BibLaTeX though, because that one is much better. So what else do we have in the chat?
I guess there was a bit of discussion just about using overleaf or setting up your own tech distribution. And I think we're sort of recommending use overleaf at the beginning because it's going to be much easier to not have to fight with the distribution set up and maybe commands not working. It's quite easy these days, but I'm speaking from a Mac perspective, and the tech distribution is quite straightforward, and I installed mine years ago, and I don't think I've updated it. So
yeah,
Overleaf works.
Yeah, Overleaf works. It's nice to start with, and then you can, when you have some time during a weekend, you can install the entire tech distribution on your computer locally, if you like. It is installed on student shell, I'm fairly certain at least. So you can compile stuff command line there. So if you do all the tech on student shell and you compile it, then you can download the PDF and enjoy its beauty. So that's a way to simulate it. Otherwise, you can install the tech distribution on your computer, and that will be one of the largest installs that you've ever done, probably. Because if you install the full tech distribution, it's usually a few gigabytes that you install. So still it doesn't compete with modern computer games, but
I was just going to say that's a bit.
Yeah,
you're stepping into risky territory there.
Yeah, exactly.
You will nope.
but still it beats most other stuff. All utilities, everything in the utility category, it will beat that.
Quite an important question, just I guess we've covered it a few times, but it's worth repeating. People are wanting to know, is there any way to make clear that they have passed the task so they can move on with it?
Well, actually, before these assignments disappeared from Canvas, I think I had marked them, so you can mark that you're done with it and move on. But as soon as you've done it, and it seems to work properly as it's specified in the assignment, then you can move on to the next assignment. Because basically, for instance, so if the first assignment is basically if you've signed into Student Shell, we will see it and you will pass that assignment. So if you've managed to log in, it's fine. And if everything disappeared now, yeah, it's a one-liner to do it again for you. So I'll notify everyone if they have to just sign into Student Shell and exit again once. For the second assignment, that's just creating a repository. And the third assignment is committing tech into that repository. So basically, once you've created the repository, you're done. Continue with the tech. And if you pass the tech, the LaTeX assignment, then by definition, you've passed the second because you have committed it to the repository, which means you must have created it before. So then when we grade the LaTeX assignment, we will pass the second assignment too.
Okay, that's pretty clear. Yeah, okay. Haven't seen any more urgent questions. If I've missed anything, pop question into Canvas. We try to go through that, and yeah. Otherwise, I think we're done. We just ran over 9.
Mm-hmm. Excellent. Okay, so good luck playing around with LaTeX. The tutorial that I linked to, that one is really good because it's most of the people who are developing that one, they are part of the core LaTeX team. So it's really up to date. There are a lot of outdated resources out there which you shouldn't follow. So do this tutorial and you'll be doing great. Yes, if something's missing, we'll let you know, and you can complement it, and we'll be very nice when we do grading too. So we're not a pair of mean bastards, so it'll be fine. We're more forgiving than we seem.
Very quickly, William wants to know if you can use the tabular environment instead of the listings package. It says use listings package, so
yeah, and you don't want to use tabular for typesetting source code. You want to use the listings package or inputting files. So you want to use the listings package for what the listings package is for, which is listing source codes and contents of files and so on. So for instance, every code listing in my slide is made with the listings package, because then I can just have the source code in a separate file, and I don't have to have it in my code, and it will typeset it nicely, add line numbers and everything if I want that. It will do syntax highlighting and things like that. So tabular is for tables, for typing up some limited amount of data, so summarizing some data. So they are used for different things. Yeah, so you can't use add -p for a newly created file because that file is not part of the repository, so there is no difference. So once you've created a new file, you can use git add and then specify that file. And then if you do some changes to that file again after that, before committing, then you can use add p, because then it's sort of almost part of the repository, so Git knows about it. Excellent. Okay, then I think we round off, and happy teching. And yeah, if there's anything, post the Canvas. We'll keep an eye on that and try to answer as quickly as possible.
Quick question.
Yes, shoot.
Like repository, should it be public or private when you create it?
Good question. I think once you make it, yeah, make it public. I think that's probably safest.
Okay, thanks.
You're welcome. Then that's safest for this course, because then I know at least we can access it automatically without any problems. But I mean, for other courses, then maybe it's fine then it's better to do a private one and you just hand in the PDF or something. So it depends on the course. So don't always make it public. But in this course, make it public and you should be fine. Excellent. Okay. Thanks for today, everyone. And good luck finishing the assignments, and see you in Canvas if there are any questions.
All right.
Bye.
Bye-bye.
Hey, bye.